Welcome everyone to this video. We are going to discuss question number 8 of the chapter of audio optics, which came in JEE Advanced 2015. Let us begin. Basically, the question says that you have some kind of mirror, concave mirror, and a lens placed in front of it. Distance between lens and mirror is 50 centimeter. So first you have to obtain an image from this particular system when they are present in air, and then the whole system is immersed in fluid of refractive index 7 by 6 or some kind of medium. So then the magnification changes to M2 after reflection from the mirror and refraction from the lens. So what would be the ratio M2 by M1 that we are supposed to find? So let us begin. So first we'll do our reflection from the mirror, which would be same in both the cases. So let us find out what that reflection and magnification is. So object distance is minus 15 centimeter. The focal length which we have f is equal to minus 10 centimeter. So 1 upon b plus 1 upon u is equal to 1 upon. Then 1 upon v is equal to minus 1 by 15 is equal to minus 1 by 10. This implies 1 upon b is equal to 1 by 15 minus 1 by 10, and 1 by b is equal to 30 to minus 3. The image distance is equal to minus 30 centimeter. So this is the image distance obtained in the reflection from the mirror. This means that the mirror is forming an image at a distance of 20 centimeters from this lens. So the focal length of the lens itself is again 10 centimeters. That means the image is being formed at center of curvature of the lens. So the image will be formed at the distance of same 20 centimeters. So the net magnification in this case, in case number 1, would simply the magnification achieved in the reflection from the mirror, as the magnification achieved in the refraction from the lens is 1. This M1 double dash is that for the lens, that is 1. So this is simply minus V upon U. So this is minus of 30 divided by minus 15. This value is some minus 2. This is the magnification which we have achieved. Now we will do this whole question by immersing the system in a fluid of refractive index 7 by 6 as is mentioned in the question. So the refractive index of the surrounding medium is 7 by 6, and the object is placed at a distance of 20 centimeter. Whatever magnification which we achieve in this case would be our magnification for the whole idea. So focal length f, what our focal length is let's say some 1 by f value. has. This value we know as 1 by 10. Refractive index of the lens is given to us as 1.5. So this is 0.5 into 1 upon R1 minus 1 upon R2. So this value is some 1 by 5. So in the case when we have another medium, we'll say this other medium comes in denominator, that is 7 by 6 minus 1, and the earlier value of R1 minus R2. So this gives us the value of 1 by f as some 9 upon 7 minus 1 into 1 upon 5. This is 2 by 7 into 1 by 5. So that is 2 by 35. So f is equal to 35. Now let us try to form an image. P is the image distance. So the image is formed at a distance of some value P. So after calculation, this value of P would come out to some 140 centimeter, and the magnification M2 would come out to be 2 times 140 by 20. That is 14. Magnification in the first case is 2 only. So this ratio M2 by M1 is equal to 7. So thank you for joining. Have a good day.